people take pictures of it too. So,
Oh, really?
as we left, another group.
Okay.
So, but I was thinking that's probably.
Oh, gosh, yeah.
Yeah. By this time of year,
yeah.
Walking that bridge, people always try to
Yeah.
Yeah, selfie sticks.
Yeah. See the Hare Krishnas?
No.
This used to be, I run across 2 big groups of Hare Krishnas. Hare Krishna songs and bands.
No kidding. I
one on the bridge,
yeah.
Then one in the square. But the extra far.
Yeah. No, I didn't. I haven't had that pleasure. Hi.
What's up? Nice to meet you.
Hey, Alyssa, we met in the FCCU a long time ago.
Yeah. You guys are.
Yeah, we're good. We're good. Thanks a lot for all the help.
We'll see what happens.
Yeah, I know.
Yes, sir. All kinds of stuff that you're doing here today is IT transition, and you had a whole bunch of parties, and you had a workshop in that city, and Alyssa came to the workshop. Yes.
Which makes sense.
Yes. Yeah. So, I mean, 4 people. Oh, really?
Did it just come out? I didn't see it. Maybe distributors are listening. Oh, that might be.
Oh.
You would probably have to do something. I'll ask them.
Yeah, Robert's going to free it up.
What's 320? Yeah.
We're going to do this first.
Yeah, we're good.
I'm sorry, I thought I was looking at 3:30. Okay, let's go ahead and get started. Welcome to the the first meeting of the Modern Working Group, newly minted as such. I apologize for the late start. We have a virtual queue you can see on the other monitor there, and there was a message sent out announcing that 45 minutes ago that never got through for various administrative reasons. So hopefully anybody who is remote, if you want to, there is a virtual queue here so that you can take advantage of that for asking questions, and we will hear your questions rather than having them needing to be relayed through a Jabber scribe. So first order of business, well, the note well. Please note it well. Could I get a volunteer to be a scribe for the meeting? A note taker. Anybody, please? Okay. Was that a volunteer? I mean, I can look at people, but
Anyone?
that's hardly fair. Anybody willing to scribe for the meeting? Thank you. Thank you. Okay, do we need a Jabber relay since we've got the... Great, thank you. Thank you. Okay, so agenda bashing, we have 4 presentations. Tom McGarry is going to talk about the newly revved Modern Problems draft. John Peterson will spend some time talking about architecture and about applicability of Turk. And then Henning is going to get up and talk about some, I should have on the agenda pre-modern prototyping instead of modern prototyping to be more accurate. Some work that he's been driving. So real quick, the review of the milestones that we have for the working group ahead of us based in the new charter. If you haven't seen it, first milestone in March of next year being the architecture draft, and then a series of drafts after that, culminating in if we keep our schedules, June of 2017. So just to make sure that everybody's in sync on what we're attempting to achieve here. So with that, Tom.
Afternoon. John and I did a new revision of the latest Modern Problems draft. And John, I love the fact that you called it Modern Problems. Every time I save that on my laptop. You can go to the next slide, please. So what I'll focus on is really what's changed from the last draft to this draft.
It's working. one of the modern problems.
One of the modern problems.
I don't know why it's been so slow. Okay.
Back one more. Yeah. So the outline of it is there's a problem statement. There's nothing new there. There are actors. There's some new stuff there. There are mechanisms that we're going to use. There's not much new there. Use cases, which is all new. There's a lot more to be done on it. And there is a new section called distributed registries and data stores. That's all new, although we made reference to it in the last version, but lots more work to be done on that as well. I think one question we'll think through as we go through it is, should that last one just be integrated into the rest of the document as opposed to being a separate section all by itself? So we'll spend time mostly on the actors, the use cases, and the distributed registries concept. Next slide, please. Just to repeat again, the problem statement, basically it's utilizing telephone numbers for internet telephony, and the mission is create IP mechanisms for the management, administration, and routing in an IP environment. So actors, so what's new in 01? We separated the numbering authority from the registry. The numbering authority is really intended to be a regulatory role. That's an entity within a country that makes policies around what should happen in a country. The registry is an operational entity that implements those policies. They could be one and the same, but sometimes they're not, sometimes they are. But what we're going to really focus on when we're talking about protocol work is really the work of the registry, not the work of the numbering authority. This concept of service enablers, and these are entities that work with the communications service providers to enable service. Think of these as like equipment vendors and system integrators and other entities in the ecosystem that help activate service but aren't communication service providers themselves. So one thing that we don't have in here is, as I was going through this deck, should there be two categories of actors? They seem to kind of fall into two categories. Those that are doing the administration, the numbering authority, the registry, and the government entity. And those are really doing the service management, communication service provider, service enabler, user. Just kind of an open question to the group. And then we have this concept, which is new, of an assignee and a delegate. The assignee is somebody who has a direct relationship with the registry, and that entity was allocated or assigned the number from the registry. A delegate is somebody who gets the number from somebody else. They get it from another delegate. This good now?
So I'm just curious in terms of, as you describe, heading towards 20, as you describe the actors, there seem to be kind of two types of actors that you described, namely logical ones that are, it's good if we have the same name for those, but they don't actually participate in any of the protocols as such. So for example, if you have a separate regulator role, there wouldn't be the endpoint of any HTTP packets, say. And if they only have that role.
Right.
And the other ones are, well, again, one's actual participants, which we tend to focus on in the protocol document. So it might be helpful just to avoid confusion, because then otherwise somebody assumes that there is a regulator to whoever protocol, which probably, that's called an ex parte filing, but not a, for those who know what that is, but it's not a HTTP one. So the other one, in terms of the delegate, and I don't know if you have that in mind, is, and I'll talk about that a little bit in the pre-modern prototype because that came up, is that we actually have implemented as kind of a possible idea is that consumers, as one example of what you might have in mind for a delegate, would have access to some limited information about their subscription. So kind of what, in the old days, you would dial a special number to find out who your carrier is. That's obviously, well, you want to find that out more efficiently now, and you may need that for porting, in the sense that you might have a porting pin, for example, that you would either set or retrieve if we go to a pin-based model for porting. So yeah, I think that makes sense. Probably should be clear as to whether that type of end user is included or if it's really just the alt-spid essentially model where it's a VRS provider, say, for example, which is a somewhat different role.
So in my mind, the delegates are what we typically call resellers, and we know there can be lots of resellers. Resellers can give numbers to other resellers, we can give them to other resellers, give them to other resellers. That's how I think about it. I think of the user as the actual user of the service, the one who has the communication service themselves. There is a question, however, whether the user, and we have this question here later on, by the way, whether they can delegate to someone else. Right?
Does
like,
that matter?
Like the
I mean, from a protocol and action perspective, as a policy matter, it matters. I mean, say maybe if somebody declares a reseller to be something different,
right?
I mean, like a Resborg type model or something, right, which is not a carrier but not a end user. Right. It's a separate category that's created by. And from a protocol perspective, since we're trying to stay out of policy, right, is it might well be, in order not to create too many roles, that delegate is anybody who isn't entitled to get a number directly, but should at least, in my view, have some limited policy-defined roles of access and or right access to selected fields in their record. Right. And I'm not sure it matters whether they actually then, like you said, if you can delegate, I can become a reseller of one. Right. And that doesn't really matter at that point.
Yeah. Thanks.
Yeah, John Peterson, I certainly agree separating out the categories of actors into people that are actually in the protocol, like are going to be participating in the protocol flows we anticipate, versus those who just kind of have an ancillary relationship to the architecture is a useful distinction. And I think there's already a bit of trying to capture that when you see the discussion of how the numbering authority and the registry are different, and the numbering authority is not expected to be involved in the protocol interactions. The way that I was thinking about assignees and delegates, at least in this revision, was that this was kind of a role that any of these actors could play. I think this is actually your next slide, right?
Right.
I mean, maybe you just flip the slide, and this will help. I mean, I think, I wouldn't think about assignee and delegate as something separate from user or service enabler or CSP. It's a role that those things can play in various points to be either an assignee or a delegate. It's a quality you have that as a CSP, I got my assignment directly from the registry versus I got a subsequent delegation from somebody else. Okay.
Chris Went, Comcast. I'm wondering, can we sort of define that in the context of who's making the HTTP request or something like that? I think that would make it a lot clearer for me. Like which actor is the end user, the actual subscriber, able to make an HTTP request, or is it somebody doing it on his behalf based on a policy?
Like what HTTP request?
To the registry or to whatever.
Yeah, I mean, so I think what it means to be an assignee is to have like a business relationship effectively with the registry yourself. And so, yeah, you would have credentials and some direct business relationship with them, whereas a delegate, say, might have a business relationship with AT&T, with their provider, right? And they would then have that direct relationship with them, but not a relationship with the registry.
Yeah, I mean, I think this illustrates, Henning speaking, illustrates a little bit of that we're commingling two things, namely because we envision, and we had this discussion on the list and previously, that we're not just envisioning a kind of a national regulatory authority and its delegated service provider, registrar type of entity, but we're also envisioning that in a PBX type of context or even in a consumer context. So if I go to Comcast, not likely as a residential consumer, but maybe as a small business, I might use the same protocol to request a number from that entity, and I see no reason at that point. I'm a client. Maybe that's what you were referring to. At that point, I'm a number assignment client in some sense, and that can be hierarchical, like you indicated, and that gives me a certain role, namely I can say, give me that number if it's available, or give me a number in area code 201, or whatever we end up implementing in terms of the query. And then it really doesn't matter as to whether I'm a reseller and somebody else downstream does the same thing again, or whether, you're iConnective or Newstar or somebody, and somebody, a carrier with a certificate comes to you. That's a policy question as to what they can do. So I'm a little worried that the names are implying a model that is not quite general enough.
Good feedback.
Sure. I mean, but to be clear, this does say that a user can be an assignee, or a service enabler can be, or a CSP can be, right? So it's nothing is prohibiting that's in this.
One more comment. Chris Wen, Comcast. I mean, often that happens sort of indirectly, like a consumer calls the HTTP service of the service provider, and then the service provider on their behalf. So are you equating those two, or you're saying it is a direct relationship?
No, I'm simply saying that they could possibly, not that we would mandate that, they could possibly use the same bits on the wire. So they would use an HTTP JSON request, except I would go, if I were to become a Comcast customer, I would send it to getmynumber.comcast.com or whatever, and Comcast would send it to whatever, lnpa.org or whatever. So, but the request is roughly functionally the same. I would ask for a number in a certain area code, say, and the answer can be yes, no, or you're not authorized, or whatever else it happens to be. But from the effect afterwards is, at a high level, pretty much the same. An entity has marked a number, namely in one case it's you out of your, and that might actually trigger a chain. You might then go off immediately, if we do real-time inventory, you may immediately go off to the same request with a different authorization to the stand-in of a big database. So that's all I'm saying. That's why I'm worried about having kind of implications of who they actually are in real life, so to say, namely how they make their money, and how we would classify them in rulemakings. All of that, I would like to suggest at least that we pick terms that reflect their role in the numbering problem, and recognizing that that can go down multiple layers.
I think you're kind of getting, I asked a question on the last slide that says, isn't delegate actually an actor? I think you're almost saying that you shouldn't have the other actors up there, that a delegate should be the actor who's getting numbers from somebody.
Yeah, I think maybe we'll discover this as we go, but is the interface to the end user going to be the same, have the same requirements as the service provider? I mean, we could expose that exact same interface to the user and just sort of proxy it in some sense, or we could add to it because we have some other value-added services and blah blah blah. So that's, I think, maybe where I'm hoping to get a little more clarity, so at least I can understand what we're talking about.
I do have to think that the user has different requirements than the communications provider, right? The communications provider may have a need for lots of inventory, whereas a user wouldn't. That's at least one example I can give.
Well, but this is what these use cases that we're going to get to here are intended to expose. And the point of enumerating these actors is to try to say there are a set of use cases where we want to be able to talk about a user getting this versus an enterprise getting it versus a CSP getting it. That's what use cases are for, right? They're for saying what are the practical things people want this work for out in the world. And I mean, I think it was our obligation, we understood from the discussion last time, to develop these use cases. In order to develop them, we need to have some kind of actors that are going to map to the real world business practices that we're hoping to model here.
Martin Dahl, AT&T. I mean, I agree with Henning in that, keeping it up at a level of, assignee delegate, but then, with respect to, the relationships and whatnot, and then leaving it up to policy of who is actually the assignee and the delegate, would take a lot of the politics out of this room. Mm-hmm. Of course, we then have to enter, the realm of what, if you're talking a protocol, what actual information is conveyed. And then even with that, though, it's really going to be policy that's going to dictate what information is really sent between, the end, whether it be a carrier, service provider, or end user in the end.
And then certainly for Henning again, for the use cases one, if you want to kind of tell a story, I mean, what these typically would be, I see no problem of informally kind of defining. I mean, for example, this could be a reseller type of thing, and we don't quite know yet as to whether the information is exactly the same type of statement, because we don't at this particular moment, without kind of elevating them to what sounded like a formal protocol role in that. And so that's why maybe we are essentially saying the same thing, just I'm a little worried that we define all these roles that imply more policy than we intend to at the moment.
Fair enough. Yeah, let's get to the use cases eventually, and we'll probably get back to this discussion. And this, I think we've seen this slide. We know what we're talking about here. Let's see, the mechanisms. Again, not much changed here. There's basically three mechanisms we're talking about: acquiring telephone numbers, provisioning telephone numbers, what we call management, and retrieving information about telephone numbers. Again, not much new in this section. We go to the next slide. The use cases are divided into three: acquiring telephone numbers, accessing telephone number information, and then service management, which is really once you have one, how do you manage service, moving it, changing it, deleting it, etc. So I'll go the next few slides. We'll go through some of those. So the first one in acquiring a telephone number is communication service provider acquires a telephone number from a registry. The communication service provider enrolls with the registry. They make a relationship with them. They say, here's who I am. They probably have to provide some qualifying information as to who they are. I guess one question is communications of qualifying information part of this protocol? Is that something that we do out of band? Worth thinking about? John?
Yeah, John again. So this is something Tom and I were discussing kind of as we were trying to put this together. I guess my intuition was, I certainly don't imagine like the underlying modern protocols are going to give like utilization forecasts, when you put in your request for a number, and that something automatically is going to happen then at the registry that's going to decide whether or not your story is good enough for you to get these blocks. Obviously, there's going to have to be some out-of-band information that a CSP or even a user, some out-of-band relationship they have with the registry, and certain information is going to be shared. There's certain information that the registry is going to know by virtue of its understanding the numbering space. And so, I think it's worth mentioning that this is probably a component of the business process. But yeah, I would ultimately say that's probably not in the scope of the protocols modern is going to be designing.
Yeah. So then the communication service providers request a telephone number. And by the way, they could be, as I said before, they could be asking for inventory. They could be asking for, at the time when someone has come to them, the text in the document goes through a little more detail on that. They could request it from a specific pool. Is this mobile? Is it wireline? Is it in this region? Is it in a different region? And they may need to, again, to provide additional qualifying information. And this is just, John mentioned things like utilization forecasts, maybe that they have access to the PSTN in that region or something like that. They may need to send as well.
And again, we're Henning speaking. We're just at the level of kind of describing how the overall process works, but in terms of scoping the problem, I wonder if we are seriously considering that we would have an abstraction of an RUF now encoded in XML or ASM1 to fit with the vintage of that. In the protocol request. So, what might be useful is to say that typically or currently, because again, we might evolve into a model if numbers become more like 800 numbers, for example, or there are 800 numbers where it's essentially based on can you pay, and don't hoard, otherwise you're in trouble, or maybe not. I would just be slightly careful, again, not to, because we don't want to have these endless discussions as to how things should work.
Right.
What's the minimal set of functionality that we want to support, and if the additional qualifying information is unlikely to be submitted for each request, then we should maybe spend very little time on it. If you do believe that there is a realistic way, and I've never had the pleasure of looking at an RUF as to what they look like. I suspect it's a Word document of some sort, as to whether we would really envision that would be carried in band per request, or whether there is some out-of-band mechanism where you submit your RUF every month and then you draw down your allocated amount of numbers.
So that's, utilization forecast is the least of the problems. We actually get faxes of interconnection agreements. So yeah, that's this type of stuff. I think
we want to attach GIF images to this protocol.
Yep.
Chris, Poundcast. I'm wondering, are we explicitly saying that inventory type things, block requests, has to be part of this, or? We've looked at that a little bit from a distributed database point of view, and that makes the problem a little harder, maybe a lot harder.
My opinion right now is that
just making a comment. See if there's any feedback on that.
It's kind of the way the world works right now, just about everywhere. So I think it would be hard to ignore it, but it's a good comment.
Yeah, I guess I would say I've been assuming some kind of block operations, batch operations are going to be in scope for this interface.
Yeah.
And this would be one of the things that might differentiate how a user's interaction with the registry differs from the CSPs. Okay.
So, think about a business that needs 100 block numbers. They want those consecutive, presumably. They don't just want random numbers out of some area code.
Yeah. So then the registry assigns the telephone number. They verify the profile and qualifying information. They remove the telephone number from the available pool. They update metadata related to telephone number, perhaps metadata around the service provider themselves. They provide a credential to the service provider that this is your number. You can, it's now yours. So that's the. By the way, there's a bunch of use cases I obviously don't go through, but that's the kind of one of the main ones in the beginning. Once you go to the next slide, which talks about a user delegate acquiring telephone numbers from communication service provider, and I'll say that rather than go through all of this, it's actually very similar, which I think is a point that keeps on being made here. Somebody enrolls with service, somebody requests a number, somebody, the entity that's request does maybe some kind of verification. The point was made, maybe they don't have to do a verification, which is pretty much for geographic numbers the case today. And it's assigned from the available pool. The communication service provider, if they got it from their own pool, they need to note in their pool that's not available anymore. They update metadata. They provide credentials. It's basically, actually, if you go to the next slide, I just did it's a very similar process, which I think is a point that's been made here now a couple of times. Uh-oh.
Hotel food makes me fat. Might as well get the exercise. Pete Resnick. So some of the after the assignment happens stuff in use cases, metadata update, etc., is completely internal and not protocol. Some of it.
Okay,
And-
sure.
And I was having a hard time going through the use cases, trying to get my head around which was going to need to be in the protocol, which sort of the function of the document is to tell us what we're going to have to build,
Right.
and which was, okay, this is stuff that's going to have to go on, and where that line is going to get cut. So it would be very helpful to sort of make sure we separate out those things.
Thanks.
Okay, so going back to the request, okay, within the existing model, the requester is typically a carrier to which whom you're making request of already has a lot of information about you.
Mm-hmm.
And the government authority also has control over you to some degree, okay? With respect to end users or even corporations, typically those two entities have very little information about either a corporation or an end user, but it's really the carrier who those users today have a subscription with, have a significant amount of information about. And so, with respect to making the request, it would seem as though there's a lot more information that's going to be needed for the quote non-traditional roles making a request versus the more traditional that are, the information is already there.
The profile data, I think you're talking about. Yep. Mm-hmm.
Interesting. But let me speak to just one of Pete's things first, which was certainly the part there that says credential provided is something that is going to involve some kind of a protocol operation. The degree to which that's under modern scope, I think, is debatable. But it's also the case these use cases are kind of intended, I think, to explain the broader ontology in which the protocol interactions occur. And so the problem statement is not the spec we're going to build to. In the sense of it's not an implementer's guide to these protocols. This is really just, again, trying to give a broader sense of the ecosystem in which all these protocol operations will actually occur. To your point, Martin, I think it's actually enrollment is where all that stuff needs to happen. It's enrollment. Enrollment's going to be different. If end user can get a number from the registry, the end user is going to have to get this relationship with the registry, and it might be similar to the way this works to get a DNS name today, where you gotta get good information about them. You gotta get credit cards. I get these annoying messages from Network Solutions every once in a while telling me, did you change your address, because it's actually a big deal. Enrollment will entail that all that stuff happens. But that's going to happen at that one-time hit, really, and then I think the requesting will be relatively straightforward after that.
Andrew Allen. So the request procedure, is it going to take into account the vanity type numbers? So particularly 1-800 numbers, often there's letters associated with those with the digits translations, and so then some people like to have specific numbers, particularly Chinese people like to have as many 8s as they can get in their number as possible, rather than just request for some random number. I think that needs to be in there if we're going to replicate what people often do right now, whereas when they call a service provider, they ask what kind of numbers are available.
I could see that we'd have to say somewhere in here the entity asking is asking for a specific number, or they're just asking for a specific number in a pool, or they're just asking for any number, right? I don't know what we're gonna, I don't know what we're not gonna make any policy decisions about that.
Or the ability to be able to be given a choice of some numbers, or put a set of requests in for certain types of numbers.
That's right.
Chris on Comcast. I think that will be an obvious result we want from this, the ability to allocate a number in fairly real time, so you can look at the unallocated numbers and select it.
Mm-hmm.
Given that given that the number of unallocated numbers in a system where you essentially you may not have a pool model, as deep a pool certainly as we have today, an inventory type of model. Essentially, it means you probably query for an area code because that's what you want, and then maybe a prefix because that's what you have. Mm-hmm. And so in the prototype I'll talk about, which I won't mention again, is you're allowed to specify the prefix, and if you have something, you'll get whatever is available, and that gets you all the way from area code to I want a specific number because I want to see if that's available. But listing the numbers that are available in practice I mean, it's probably going to be in almost, you know that better, much better than I do. I suspect in almost all area codes, that's going to be millions of numbers that are going to be available.
Yep, about 4 million. U.S.
Oh, sorry. I was going but I mean, if it's more of a search thing, kind of like when you want to get a domain name, right? You can search to see if that domain name's available.
That's right. Yeah. That's a good point. Sure.
Sanjay Mishra. So just to what Henning just said, I mean, this is on the very simplistic level. Today, a subscriber, when they subscribe for a phone service, they already automatically get a choice to pick up the area code, and they can also get the prefix as well. So that's already in there for the subscriber-based model.
Right. Yep. Okay. Next slide. So accessing numbering information. There's two types of information: administrative and service. That's how we've described it today. Quite frankly, I think it could be better done throughout the document. It kind of picks up here towards the end. Let's see, information can be stored at the registry or the communications service provider. Others may need access to that information, so at the very least, the registry would need to tell them how you would get that or who you would get it from. Access to information would likely be authorized based on the requester. Next slide. Accessing numbering information, the service information access. Network nodes need access to provide service to their users. Again, registry could contain a reference to the correct service provider. Alternately, registry could host the data. Again, authorization of the requester may be necessary. And then we have privileged access for government entities, and this is part of accessing numbering resources and having numbering resources. The policies are likely going to allow government entities to have access to some information that you're giving in, to the registry, or hosting yourself. I'm sorry, and having point proxy to by the registry. Next slide. Service management for numbers. So there's a few different categories here. Updating service information, service data from a user changes, the CSP updates it. They have to update the registry. How do they update other entities that need that data? Updating administrative information, user changes their contact information. How does that get updated? Who's hosting it? How does it get propagated out if necessary? Changing service provider, better known as number portability. How do entities do that in this world? Old service provider have to delete data. New service provider have to provision new data. They'd have to issue credentials. Terminating service. Let's say a user cancels their service. They return the number to the registry. The registry would delete numbering information that they have other than maybe relevant history. Would likely age that number, maybe not. But these are basically, it's the 4 sections below is the service management so far use cases. And then next slide. And here, like I said, this is brand new. This needs more work on it, but we put a section in here that's distributed registries and data stores. The concept is with distributed registries that multiple registries maintain telephone number data. They update each other when there's a change. Communication service providers would have a relationship really with one registry. It would be up to the registries to make changes, propagate them out to the other registries when that happened. Distributed data stores, to the extent that service providers are hosting service data that needs to be accessed by others. That can be something that they propagate out themselves. And there's multiple data stores of this information, and service providers basically have a duplicate copies of everybody's. The challenges, of course, is to avoid clashes, make sure that 2 registries aren't assigning the same telephone number at the same time to 2 different entities. Also to synchronize the data, make sure that the data stores all are up to date in time, and that there's not misrouting because things are out of sync. So we wanted to make sure this concept was in there. Like I said earlier, we probably might integrate this better into the other sections of the document as opposed to having it be a separate section itself. And then next slide. So next steps is really another iteration of the draft based on feedback here at the list, conversation with others, and that's all I have on 01.
So just Henning, one quick comment on the previous slide, just before I jumped up.
No, I'm sorry.
If you don't have a minute. At least based on the prototype, the one relationship, one registry wasn't strictly necessary. So I've actually, at least in some layers, envisioned that for redundancy purposes, you could imagine that some carriers and others would actually maintain multiple relationships because the information is synchronized, as you said, between those. And so I wouldn't, I mean, this is mine item, but I would not, that doesn't seem like an inherent necessity. You do want to make sure, we assume, in the prototype, and this is again, because just to keep it simple, we're assuming that a single actor knows what all of its tentacles are doing, so that you don't worry about that a single actor goes to two different databases and requests the same number at the same time, or does something other stupid. I mean, that if you update the number at two different registries, that they got the ordering worked out so that they don't, I mean, that we don't have to worry about timing between a single actor. That I think is kind of what you're implying, but I'm assuming that actors are not internally consistent in what they do, so that we don't have to worry about global timing, for example, so that, you know what I mean.
Makes a lot of sense. I hear you. Any other comments before?
Chris Wynn, I would totally agree with that. I think you should have multiple relationships.
Makes a lot of sense.
Yeah, and just in terms of the future of the document, John Peterson again, sorry. I mean, it'd be great to get some text or something kind of relating to what you're experiencing with the prototype in this, because we just kind of put something together because we wanted to make sure that there was more than just a placeholder TBD in there for it. But honestly, getting some text would be great.
Wow, first, I wish this working group was happening like 7 years ago. When we did all of this work around this exact topic for a long time. Daryl Malice. One of the questions I had.
I'm just curious, which successful and not successful?
Well, there was Spearmint, there was Drinks. I was doing a whole bunch of work for Cable Labs on this. But one question that just came to mind as I was looking through your use cases is calling name or caller identification considered as part of this, because one of the things we found is that when you move to this architecture, you're no longer limited to 15-character, SS7 requirements. And so, and there's all kinds of things whenever you're sharing information or distributing things from databases. Before, where you had a separate database for calling name information, when you move to this type of registry, it can actually be integrated directly with it, or I'm meaning there's different solutions that can be put in place, but one of the options is you can integrate it with it, and then you share that information, you authenticate it, you can do all kinds of things, but I didn't see it as just a general use case relative to this. I didn't know if it should be.
John Peterson, there's a reason why there's not. Who's in the Jabber room? Is Richard Shockey, is the ghost of Richard Shockey haunting this room? So there's been a proposal to have a working group called CNET that would focus on ways of doing this, and there were concerns expressed actually during the chartering process of this group that it shouldn't tread on the toes of CNET. Now, that much said, in the administrative data that is being discussed here, surely there's going to be information that could help to furnish that. But the accessor protocols and kind of the broader questions of how that data should be signed or verified within SIP and so on is a bit of a more complicated political, I guess, matter in the IETF right now. But yeah, there's no technical reason why we could not have an accessor for this, from these registries that would get exactly that data.
And again, we had three separate issues. Namely, the CNET one was largely how do you get it from one end to the other, and to some secondary extent, how do you validate and what are kind of reasonable validation, signing, and so on type of mechanisms, which I think are far out of scope of this particular effort. But I do agree that one of the big problems today is that unless you manage to call yourself somehow, you can't even figure out what your own caller name is. So, and we could clearly do better than that.
Right. All right. Nothing else? I'll hand it off to John. Thank you.
I've been informed on the way up that I may need to be dodging tomatoes, so if you see me kind of moving back and forth, that may be why. Yes. Unfortunately, there's like this little pink box I need to stand inside, so my dodging will be confined to what I can do within this box. So I'm going to be talking about Turk in a minute, but first I wanted to up-level, and this is something I asked the chairs for, was a bit of time to talk kind of about these three deliverables that Tom previously alluded to. Why don't you flip the next slide? So what we're on the hook for, what Alyssa is going to be judging us on succeeding or failing in terms of what we produce here, are three protocols. An acquisition protocol, which is the way that you're going to get numbers. A management protocol, which is a way to just mutate, provision information, administer these numbers once they've actually been created. And finally, an accessor protocol, a query protocol, that's going to let you get data from this if you don't already know it. Those are the three things. Now, it should be pretty obvious to us at the outset here, and we're at tabula rasa right now, right? We've got some vague ideas about what some of these protocols might be, but this is the time, I think, to take a step back and ask architecturally, how do we want to approach this? What do we think these components are? What parts of them interrelate, and what parts of them potentially do not? When you think about how to do a query protocol, for example, it's pretty obvious that your data model or things you can query for probably should align with what we think is going to get provisioned in the first place. And actually, if we look historically, kind of drinks versus enum, and kind of drinks was designed to kind of work with enum, and yet that provided all this data that might not necessarily have been easy to get through the syntax of enum or even through its semantics, arguably. So since we have an opportunity to kind of look at all three of these in concert, let's take a step back just for a minute and say, how do we imagine these three protocol components are all going to work together? Surely this is a common information model. So next slide. So yeah, on the back of a Van Halen CD this morning, I sketched something that looked roughly like this as my guess of what all this might actually look like. There's going to be a common record type. Now I'm calling this right now a telephone-related information record, Terry record, as it were. We know there's going to be two flavors of info that might be stuffed into it. Some of it is going to be service data. Some of it is going to be administrative data. Service data, arguably, we think of as data you're likely going to need in real time for call processing in some fashion. Administrative data, perhaps it is more elastic to access it. This is data you might need to do triage, do billing, things like that after the fact. I don't think we understand this distinction very exactly right now, and this is one of the things we're going to need more crispness on going forward, but our intuition is that there is a distinction and that we should probably at least explore it for the time being. We know that this acquisition protocol definitely is going to push into these records some administrative data. These are the places where it's going to say things like who owns it, who the assignee is, right? Potentially who the delegatee is. We know that the management dimension of this, which is where, say, a service provider or a user might end up pushing additional data to it, might also touch some of that admin info, but is also primarily where service info is going to get populated. And we know that various kinds of entities that want to query are going to be able to get both the admin data and the service data. And this has to be pretty much, I think, how these things interact. So does this picture like roughly, I guess, what people are thinking when we look at what these protocols are? That there's going to be some kind of a common record, right, that is going to have the information that's associated with a number. And then we're going to be able to define how these three protocols that it's our job to deliver are going to interact with that. Comments, Laura?
Yeah, Henning speaking. At some abstract level, yes, I think it will be somewhat more difficult to distinguish service and administrative information, and that seems again more of a, in the spirit of a previous discussion, as to who can do what to it, and it's not obvious that we need to, at the bits and bytes level, to make the distinction simply because in the end it's a database record.
Yeah.
And the only other piece which I think matters is, the only other reason it matters to some extent is there a set of pieces of information that are shared by multiple records just for update efficiency? Just take an example, at least again to refer to prototype, is we have two levels of records, namely a Terry in your terminology and an OCN record, because we don't want to store the replicated admissive information about the technical contact type of thing in every telephone number record. And that's just, I don't think anybody would be wanting that. And so there's now, I think, the more important, in some sense, from an architectural scoping perspective, there are two directions you can take. Namely, you can say, and this may not, the first one is probably the expeditious one. We assume that there is a telephone number record. We recognize that it may link to external records that need to be updated and that have privileges for updating and retrieval and so on, primarily about holders and maybe about other things, other indirections. But they're, for the moment at least, out of scope. We don't worry about updating OCN information, for example, or what the precise format is and all of that type of stuff. We don't worry about that. We just recognize that some of that may indirectly reference things. So if you retrieve information, for example, on the query side, it may indirectly pull in, may just not give you the OCN number, which isn't terribly useful for most consumers. It will give you that that's actually Comcast or AT&T, and it gives you the technical contact information. Whatever else is pulled in indirectly for that. So I think it would be helpful, just from an architectural perspective, to recognize that we don't want to replicate, that we recognize a level of indirection that refers to external information which may be indirectly pulled in through the query, but is not otherwise part of a protocol, at least initial protocol effort, until people want to build an OCN record modification protocol.
Sure. I talk a lot about what I think records are, embedded records within records, and indirection models and so on later in this, but yes.
Oh.
Chris Wendt. I guess one comment would be, especially in the spirit of distributed database, the word management might be a little strong in terms of what the record will be. I mean, I think the records need to be fairly simple. It's sort of a shared resource that everybody's querying and putting information into. And
we've used provisioning some too. I think we really don't have that term locked down what it is, but
yeah, okay.
We call this, there's an acquisition,
a
a provisioning, and a query interface. I don't know, but there's three of these things, and
yeah,
I think we want to try to find what the distinctions are between them, the edges on them.
I think just to make sure that admin info, service info, is that really two separate things, or is that sort of, because we've talked about, for example, the URI representing the service provider that currently manages the number. You don't have to have huge sets of data to represent all this stuff. Well, maybe that's just more of a overall comment.
And a lot of this too, again, is informed by, as we look towards reuse, looking at things like weirds and kind of how they consider administrative data is different from operational DNS data. And so, we're going to try to steal, from as many other people as we can here with established work in the IETF. And this seems to be a distinction that's relatively widely recognized. Now, I think it's an inexact distinction for our purposes, and we are going to have to explore that further to see whether or not it really works. But
maybe it's just a personal preference to keep things as simple as possible.
Fair enough. Flip it. It's worth saying again, when I say that's just a logical picture, what I mean in terms of whether it's distributed, as you were just referring to, or it's all monolithic or centralized, shouldn't matter, right? The basic idea is there's records and they live in servers somewhere, and whether that's a network of servers that all replicate to each other or whatever else it's going to be. I think we want to make sure this logical picture will hold up irrespective of those architectures. And, the same goes for who the queries are or who the entities are that might want to interact with it. Right. This doesn't really make any assumptions, that logical picture about who's a user or a delegate or, whatever. Certainly, it will determine your relationship to the registry. To if you need to be authorized to do particular things with the registry, for example, that will factor into some of the decisions from that. But where we imagine these Terry records are likely to live, if it is in a registry, if it is in a CSP, is completely unspecified in this logical model. And just before you go in, I want to try to clarify, too, what I'm leading to with all of this is a question of how we want to organize the work. And so really I'm trying to lay this out to make sure that we're going to go forward with a common understanding of what our deliverables are going to look like and what we think we're going to be handing in as the corresponding to the milestones that are in our charter today. But please.
Yeah, Andy Newton. I don't have an opinion on this. I just want to know, for a point of clarity, the end users, are they always related to the phone system, calling, whatever? Are they just, if it's, hey, I just randomly want to know who's behind a telephone number, is that a use case, or like law enforcement?
Right, so we talked about government entities in the problem statement, that being an example of a case where law enforcement just wants to know who's behind a telephone number, and yet weirds is one of the things actually, and obviously there's informed some of our thinking about this, right?
Yeah, that's what I was asking.
Yes, so. That's partly what we're stealing from here, yeah.
Again, just Henning, this is just for background. The idea was there would be some kind of query whether some numbers, for example, might be more public than others, like 800 numbers, when there might be registries of those that are somewhat public and others may be private. So
I remember the BOF in Dallas, and I was kind of a little skeptical about you guys reusing the weird stuff, and now I think I understand a little more
why
about
I want to.
Yeah.
Yeah. I don't want to tread that path again. That was adequately trod previously. I think probably next up. Yeah, so I kind of got a proposal, I guess, which is let's look at this notion of having this record like a Terry information model and define all three protocols in terms of it. Like all three of these protocols are going to be operating on this same common information model. This may sound like it's a no-brainer. I think we haven't actually articulated this, though, and tried to figure out what parts of that record each of these protocols would need to interface with and kind of how they would all connect up together. And so I'm asking us from the outset to adopt this actually as an architectural decision, an ontological decision about how we're going to approach the protocol. Obviously there are going to be things about each of these protocols that are going to be different. In addition to the commonalities that we have in the Terry model, there are going to be different operations that are going to be performed. If you're querying, you're going to have a query operation that's going to be performed, and it's going to matter what the source of the query is, and it's going to matter what its subject is, who you're asking about. Whereas in a management or a provisioning model, there's going to be some kind of a push that you're doing, and it's going to matter who's pushing, and it's going to matter what elements you're pushing. Are you putting whole records in, or are you modifying existing records, things like that. So the operations are going to be different. But what I think we can achieve, if architecturally we think this is the right idea, is to have the records that these are all operating on be the same, be unified, be defined in a common way that all these specs are going to end up pointing to. I think next. And, just at a high-level sketch, and this is mostly stuff that I'm sucking out of that Turk document that I'll be talking about in a little bit. I imagine a Terry record is going to contain stuff like an authority. That's going to express what the source of this particular data was, the source of the record that you're examining. It's going to have some elements in it that are going to tell you data about it. This is where you might, if you're asking about who owns a telephone number, what the caller name is behind it, maybe that would be a record that you could access that way. Though, Richard Shockey, if you're listening, we are not doing CNIT's work here. Things like expiration, priority, stuff you generally just kind of tend to need when you're passing these records out and you expect they might be cached, or you expect you're going to have a set of records. You want to make sure you know which one has been preferred by the authority that's provisioning this. Again, I've been assuming we're going to divide it into service and administration. I certainly can see we don't understand that distinction perfectly today. There's some things I think of as pretty administrative information. Some things I think are going to be needed in real time a lot. So I think there's a lot of easy cases and then some real murky ones in the middle. Yeah, so that's roughly what I think we'd probably want to have in that. Now, of course, these things flip slides. The whole question then of how you transport or encode these records is something that, in keeping with the previous Turk model that I espoused, I'd want to be pretty open about, pretty open to alternatives. We should define transports and encodings by relying on well-known standards. We're not here to design like new protocols. We're not here to rethink anything about the way you push data blobs around on the internet. There are many, many good ways to do that, and I think it'll be relatively easy for us to converge on what those are. There are edges on that, though. I mean, especially we want to make sure that we get some of the low-level encoding details right for what we think the important use cases are for this, and make sure that, especially if we believe there's going to be digital signatures that are going to end up being involved with establishing who the authority was that generated particular records, that we would like to have survive intermediaries or survive this kind of store and forward process of being provisioned by one protocol and then later accessed by another. Yeah, we got to make sure that we get that encoding stuff quite correct. But the way to do that, again, is to think about all these three protocols at the same time, right? And to make sure that we're looking at this common data model that they're all going to operate on and saying, okay, then we understand the cryptography as it's going to be done here is going to be exactly what we're going to expect on the other side. And that's how we know the end-to-end security for this is actually going to work. Next. Oh, yes.
I think the words data model are probably important here in terms of how we look at this problem. I would advocate JSON, which is sort of infinitely extensible and makes a lot of sense in the current world. But I'm not prescripting that or anything like that. But I'm curious what we think the data model will look like and how extensible it has to be. Or, again, sort of in the theme of being simplistic, can we have something that really is tuned to telephone numbers and call it a day?
Yeah, I think we're going to crawl before we walk in this, yes. We're going to define something that's simple, that we believe has sufficient extensibility properties that in any JSON thing we build is going to have that property, right? And I don't think we need, but I am arguing, let's look at this from the semantics first and figure out what we think each of these protocols need, what kinds of operations they need to perform, what the data elements are they're going to operate on, and then let's worry about how we're going to jam that into a JSON object, yes.
And Henning, I would imagine that we, like always, will have essentially a very small set of presumably generic information elements that we imagine are near-universal, even if uninstantiated in any particular instance, and then a mechanism which we can have our usual arguments as to what level of IANA pain we want to impose on the registrant of that option, and the only thing I ask for, let's not have an option that starts with P dash or X dash. That's the only option, my only suggestion at this point.
Duly noted.
Dan York, you mentioned representation of cryptography security, but when you talk about this as far as transport and stuff, I'm assuming we're going to figure out how to make it secure from end to end in some way, or not?
Well, yeah. So we're going to be saying this probably goes over HTTP, right? I mean, and we're going to have all those HTTP 2.0 goodness things go along with that. So, I mean, there's going to be that, yeah. But I'm much more concerned actually about making sure trust associations persist between the authorities that generate these records and ultimately their consumers, given that there is a lot of kind of store and forward and intermediation that we anticipate in the architecture. And so there's going to be some level of digital SIGs, I think, that are going to live in the elements themselves, in the objects themselves. And then there will be obviously transport layer securities that we can invoke outside of that.
Okay, I was hoping we were thinking that from the beginning.
We're thinking that from the beginning.
Chris wanted to mention if we can follow the CRUD model and put rules around that, that's pretty straightforward as well.
Definitely, yeah. This is going to be the easy part, I think. It is. Like, we're all going to, I think, converge very quickly on those kinds of details. Yes, Peter.
Peter Koch, and this might be a completely stupid question, but having learned from Enum, are you anticipating that all these protocols are going to run over the public internet?
We're assuming that they can all run over the public internet. I'm not going to prohibit them from running over private networks, if that's the question.
Yeah, probably let's turn it the other way around. So that the assumption, there is no assumption that particular spaces will only be run over private internets here.
I'm sure that there are people in this room who say that they will only run this over a private internet if you ask them. But the protocol is going to be designed in such a way that will operate over the public internet, which will be sufficient for those private environments. Because there's so much private or infrastructure enum, that's what he's asking about.
Yeah, that's the whole, that's part of discussion. The main reason for asking this is that a couple of the operational and security implications might be completely different, and if there's an implicit assumption, make it explicit or rule it out.
Yeah, we're designing
if
for.
You mentioned a DNS or DNS-like stuff, and even if it's not the DNS and something that smells like it, there are lots of implications if you do it over private versus over public.
I think, Henning speaking, I think with separating, and again, now that you said DNS, that was helpful because there's really two separable issues, namely one where you have a namespace separation, where you have a private namespace of some sort that you want to make available within a tightly confined administrative boundary. And I can well imagine that if you had some kind of military numbers, I think they have their own number, used to have at least their own numbering space. That was
their own dialable digits. Yeah, that's a good stuff.
And that would clearly be within the relevant military network only available. So it would be both private namespace and a private network in some sense. And in the corporate environment, you would have the same thing. Presumably, you would have the ability to allocate numbers to sub-PBXs or branch offices, whatever. But unlike in the DNS, I'm not convinced that we would do split horizon type stuff.
Okay.
I don't think we're trying to do that.
We're certainly not trying to do that. Again, the question of whether we would bar it is a. If you're proposing that we should specifically disallow something like split,
I don't see any reason. My argument, I think the reason we often end up doing it in DNS is because it's essentially because we don't have access control in DNS. So
yes,
we can't
and we are remedying
we're
this.
Clearly,
yes.
So it may be worth pointing out simply because many cases where split DNS is used, we anticipate not needing it here for that reason, because if you need to hand different amounts of information to different people based on who they are and where they are, you would presumably not do that based on IP address alone or based on whatever multicast domain you happen to be in, but you would basically do it based on credentials. So that might be worth pointing out simply because we don't have the enum problem.
That is indeed a lot of the point in this. Yes, Mr. York.
Dan York, because the back mic does work now. 3 points. One, Richard Shockey's not in the Jabber room, so you're safe from him right now.
Aww.
Okay. Second, to Peter, I think we definitely need to think about this as being accessible over the public internet, because there will be many things that will want to consume these kind of things as we look at all the new services, and also people will expose this over the internet in any way, in some forms. The third thing, I guess, John, I'm looking to try to understand, it sounds like you've been trying to set the stage for the further discussions here, but is the intent out of this to write up a requirements draft, or is there a piece around this?
So my real question is this. We're on the hook for 3 deliverables. Right now, they're all separate, right? They are. I mean, we're going to provide an acquisition protocol, we're going to provide a management provisioning protocol, and we're going to provide a query protocol. What I am proposing, what I'm explicitly asking the group is this. Let's abstract out what I'm calling here the core Terry model of what we think is going to be in these records. Now, when I say abstract out, it doesn't necessarily mean its own document, but there's got to be somewhere that is going to stipulate what that is and have the other documents pointing to it and relying on it. I think we don't architecturally do that. We're going to be doing ourselves a disservice for all the reasons that I've been trying to enumerate as we go through this. Because we want the security associations to persist through this, because it is just nonsensical to design a query protocol in the absence of defining how the things that are going to get provisioned that query protocol will then consume. We just have to do it this way, I think. And so my question to the group is, ontologically and organizationally, is this a reasonable plan? And if so, how do we want to execute against it in terms of the documents that we have today and our milestones today?
Chris Wendt. I guess I was applying before, why can't we have a single data model and then have actions that can be applied to that data model?
Yeah, that's what I'm asking, right? I mean, there's basically a core
can map
model
that to those things,
right? But that this is not the way our charter is currently structured, is my point. Right. So I'm here to say, should we break this out and say, okay, we're going to explicitly have a dependency of these 3 models, and I'm for giggles here, calling them Terra, Term, and Turk, for acquisition, management, and querying. Have them all rely on some common data model, either in a document or that we stuff into one of those 3 milestones.
again, I can only, Henning, I can only speak from limited experience. I want to keep that as simple as possible, at least from my limited experience, is the protocol models that we had for implementing all of these is specified in less than 10 pages.
Yes.
I find the distinction between acquisition and management artificial, and querying actually for that matter as well. So I would not.
So you think we should have one milestone in this charter for all that?
Yes.
Okay.
Unless we, at least, again, my concern is that the document model will blow up, and the document size will blow up, and the complexity will blow up. This is each one of, I'm thinking this is not fundamentally different since you've been around for that than the lost protocol type of complexity.
Yes.
And when we did extensions later for that, as we did this week, or might do in ECHO.
Right.
So I'm not arguing that we should never do anything more, but the basics, if we can't describe the basic 5 operations that we need in the meat of it in 15 pages, we've probably missed our milestone, our charter mark more than just by the number of documents. We've missed it by the amount of complexity that we're imposing.
John, just FYI, we're bleeding into your next time slot. So.
Oh, my next time slide is just to talk about an example of how we do this, which is Turk. So
yeah.
this time can take that time. Yeah, hey, PJ.
Sanjay here, John. Just a quick question. So just a clarification question. Are you saying to separate out the commonality between the 3 protocols into one core document? Core.
My primary point was let's build this core data model first for what we think is going to go into these records, right? And then define the other protocols in terms of how they interface with that record type. And do they extend it? Do they, what do they profile it? What are the interactions between them? Rather than saying, as I believe our charter does now, let's work on acquisition, stop and hand it in and be done. Then let's work on management, stop and hand it in and be done. Then
just to clarify, we do have an architecture spec.
Okay, fair enough.
That might be a good place for this.
It might, sure.
Makes sense then. What you just explained.
Colin James. Yeah, obviously, all 3 of those things have to use the same definition for the actual bits we're going to carry around. They can't be different between the things, and we need to sort that out. And I'm not really too care much if it's in 12 documents or 1 document or how it gets arranged. But we have to get agreement on those and agreement on that they'll work for both Terra and Turk in term before we know we've done with this.
Yes.
Battery died. You can use the back mic.
Thank you, sir. Okay, so I agree with what Henning and what Chris went from Comcast was saying, Martin Daly, AT&T, in that, these all need to be worked at once. And we need to keep it simple with the understanding we can, the difficult things that we may be arguing over, as long as they can be handled with extensibility.
I think we're all in agreement about that, yes.
Alyssa Cooper, just because you said it twice, John, the charter is structured to allow you to do this any way you want.
Milestones.
The milestones are the things that, and those can obviously change. Yes. I agree with the sentiment in the room that progressing the information model and the protocols together at the same time makes a lot of sense.
Like some kind of bundle, maybe.
Hopefully that's fake.
That does not look right.
There we go. Andy Newton. Wow, it got loud. If you guys are planning on using a whole bunch of different protocols, and some of them are like XML, and some of them are JSON or whatnot. Oh, that's not what you're planning on doing?
No.
Okay. Yeah, because I was going to say, if you're going to do that, then you do have to break it down into basic data elements and so forth. So.
Yeah, well, again, this is really just saying let's get the semantics nailed down in the information model so that we can then have all these things pointed them. We need the protocols, and again, the milestones put us on the hook for these effectively as separate protocols. When we say separate protocols here, though, I think as I illustrated earlier, what we mean is there's going to be a set of operations that we're going to be performing against these records, right? Okay. And they're going to be done with JSON blocks that are being passed through HTTP.
All right.
Now this thing is dead.
Doesn't like you.
Chris, just to sort of reiterate, I mean, we're talking about a database and an access protocol, and there's a lot of established ways of doing that exist. So we should take advantage of that and not try to invent something new.
Handheld is the style I go. Next. So I think okay, so I should flip back. So chairs, I don't know if chairs, you want to talk to anybody here about, does anybody think this is a terrible idea to do all these things at once and rely on a common information model, and that we really worry primarily first about trying to nail down what we think these Terry, as I'm calling them, records will look like, and then treat the other three kind of as the accessors and mutators of Terry? So that would make me happy. Yes, please, Chris. Oh. Why aren't you talking?
So one maybe potential approach is to take what Tom presented in terms of requirements and map all those requirements into actions, and that is a fairly straightforward way of doing it.
Yeah, I'm always reluctant to have a requirements process get too heavyweight, because requirements processes can be pretty heavyweight. I've got a stab actually in some slides coming up where I talk about what I think the elements are that we probably need baseline. I imagine if we just have that discussion, like semantically, what are the baseline elements we think we need? And yeah, we know we're going to have to profile it for certain environments and add things to them. I think effectively we'll expose through that what the requirements are. I hope, rather than kind of saying let's have a gating requirements document and sit on that for X amount of time. What do you think about that, Mr. Malice?
So, Darryl Malice, requirements documents are great. They're also fantastic at absolutely sinking a ship that's going. You'll just get bogged down and you'll never leave it, unfortunately. And I've experienced this with this topic twice now.
I see applause from the peanut gallery tonight. So. Okay.
The one thing I would say is that there are 2 RFCs that exist out there that cover requirements and architectures around this whole topic that I think could be mined for information that's relevant. I'm not saying that it directly parallels what the goals are now, but I think they could easily be mined and used, including terminology and crap that we hashed over for too many years.
I believe that our charter actually compels us to do precisely that for the documents you're describing.
Yes, and I did read through the charter to see that. So that'd be my suggestion with regards to this, is just to remind the group that a lot of work, and to quote many smart CEOs of startups, to be early is essentially to be wrong. And now that we're back,
we must
around,
be pretty right then.
So to come back around at this, that's all I would suggest to the working group, is a lot of work was poured into this and discussions and things that should not be rehashed. It would be very disappointing to me to see this group go down that same path and just languish for more years over the same things that we languished over many years ago.
I hope, Darryl, you can help us steer clear of that particular Scylla and or Charybdis. Next. Okay, so I just want to talk a little bit about Turk. Cycle, I know we don't have a ton of time left, do I? The only reason I'm really presenting Turk today is because it's there. So I kind of just gave a lot of hand-wavy things to say about how I imagine this stuff could all work together. But of course, those of you who know that I had this Turk document in my back pocket this whole time probably couldn't help but notice all these names seem to correspond to that, and probably I was thinking this is going to lead naturally into this having a slot in it. Next. The Turk model, for those of you that were not privy to the discussions we had about this, we actually dispatched Turk back, I think, in IETF 85 or so, and we were just going to do a working group then to kind of do it as an enum replacement. And one of the reasons why ultimately we ended up not doing that, aside from Stir taking the oxygen of that particular room, was this sense that there was probably a broader vantage that we needed to place that in, and that's precisely what this previous presentation was trying to illustrate, kind of what that vantage really looked like. But as you can see, Turk, the basic idea behind it is, and this goes into a bit of what its core operations are, they're going to be clients, they're going to send queries, they could send them directly to some kind of a server, or they could go through intermediaries to get there. That server is going to have some records in it. Those records are going to have been stuck there by some authorities. There may be multiple authorities that can say interesting things about the same numbers or number ranges. And that's the basic idea. The operations that you have for Turk are just getting a query and getting a response. Next. To kind of delve a little bit more into that and what we have anyway in Turk today, I imagine that it's really hard not to have like a monitor that I can see myself as I do this. The basic elements I imagine that would be in these queries and responses are a source, and that could include a query source like the endpoint that actually is generating a query, or an intermediary. So I imagine there's a lot of cases where things are going to be aggregated by some kind of proxy, and perhaps the server has a different trust relationship with that intermediary than they might with an end user. There are a lot of architectures that look like that I think would be meaningful for us to keep into account. But the idea is that the subject of a Turk query would be a telephone number and or telephone number range. Initially, actually, in Turk, this is something I changed specifically because this was made a part of modern scope. I used to have SPID as something you could query about. I took that out. Of course, that would be there in deference to the work that Daryl was alluding to earlier in places like Spearmint, where there's this distinction between a LUF and a LERF, the lookup function and the location routing function. And you would go to the LUF for a number first and get back a SPID, and then you would LERF the SPID to get the actual endpoint you're going to deliver things to, because there were a number of kind of walled garden-y networks that actually operated this way today. You were one of the perpetrators of this as well, weren't you? Are you here to atone for this?
I'm not the one to blame. I just have Alex Mayover. I just have one small question regarding query source. Something that we struggled for the last couple of years. What does source actually mean? Is query source the identity of someone, or is it just like a technical identifier of a box? Because we struggled for a long time to actually be able to present a different view to different identities. And remember all the discussions.
I do. So the way it's actually defined in Turk today, if I recall, is that it could either be a domain name or it could be a URI, like a SIP URI. I don't think I had like SPID or anything else like that in there. I thought those two choices would probably cover most of the things that we cared about. There's also a concept of route source that's built into Turk. This does kind of harken back to the heady days of Spearmint, the notion that I'm asking, but I want you to tell me this data as if the place that I'm launching my call from is the following location in the network, and you might think something different, or you might give me a different answer because I'm identifying this as a route source. This was I don't know if this is a notion we actually need anymore, if this is just kind of a legacy Spearmint-y idea, but every time I look at one of these IMS networks, I really think you still need it. Anyway, now there's also a notion you could have attributes that would let you narrow down what it is that you were asking for. And responses would contain a response code. We make up some response codes for this. A subject, in case like the subject is different from the one that you specified in the query. This would be a case you asked about, like say a range of numbers, and in fact there was only one salient number that there was information for, and so the response wanted to give you a different scope than you had asked about initially. And then a record, like these Terry records that I've been talking about. Flip. And you can see how, once you define operations that way, if I were to imagine there was a hypothetical protocol called term that was there to do management or provisioning, that would be TERP, I guess. Actually, I was doing Terry, I considered briefly, telephone-related data as an acronym for that, but decided I didn't actually like the optics of that in retrospect. Yes, thank you. I'm here all week. But you can see how pretty much you could map out the operations like this. And maybe to Henning's point, right, I mean, it's not going to be too hard to just put all these things right in a document and explain the differences in the operations, because it's going to be exactly the same kind of sources, subjects, records, response codes, and so on. And so I think there's a ton of commonality between these mechanisms, and it would be possible probably to just collapse them into a single specification were we so inclined. And it probably wouldn't even be that gargantuan a specification. Next. This just enumerates what some of the elements are that seem to be in play for these protocols, the kinds of things that would be contained in records. You want to have little name value pairs that correspond to. You want to be able to talk to people about telephone numbers, domain names, URIs, IP addresses, SPIDs, trunk groups, display names for those who are happy to see us encroach on the scope of CNET. And, of course, some extension fields. But the whole idea, next slide, is that you can profile this stuff out. And that, we're going to define, I think, the simple baseline in what we're doing, and then a very robust profiling system, which, to Henning's point, will incur as much IANA pain as we think is appropriate. Probably won't be much, actually, in this case, for the majority of the profiling types we're concerned about. I think we can be pretty lenient about that, provided we, again, mandate support for the stuff we think is really baseline, that's likely to be used in the majority of these cases. Then profiling it for different environments, I think, should be relatively straightforward. So yeah, start simple, but try not to paint ourselves into a corner where we can't do the things we actually are going to need to do to deal with some of the more difficult deployment environments out there. Next. So what do we do with this? Like I said, this Turk specification has been like languishing since, I don't know, like IETF 85 or something. If people generally concur with the notion that we should have something like Terry, then when we want it in a separate document, we could move that out. Otherwise, if we want to pull in management and administrative stuff into what is now the Turk document, we could do that. And it's going to start with that. Somebody else would rather do something different. I'm happy to suggestions for how to approach it. But yeah, the idea is follow roughly the architecture that I had in the previous discussion and make progress. Or certainly no, way too early to be talking about working group items or anything like that at this point. I mean, this is real exploratory still, but any thoughts, comments, suggestions, volunteers to do this work instead of me? I do a lot of this work. I can do more. It's not a big deal.
Chris Wynn, at the risk of sounding redundant, there is a HTTP post, put, and get with sort of conventional mechanisms for mapping those to CRUD operations.
Mm-hmm.
To me, that makes a lot of sense in terms of, and instead of reinventing the wheel.
We're not going to reinvent any wheels on that stuff, I promise. I mean, again, really all this, everything I've talked about has just been the semantics, right? Has not even been about the transport or the encoding. It's just been about what do we think these operations mean? Like, this is a query operation. This is a response to that. This is a push operation. This is a response to that. I'm just trying to nail, because it's going to be easy to do the...
But I think my comment is we can define that in the data model and the actions that go with it.
Yeah, oh, sure, definitely. All right, well, Alyssa?
Can you go back to your picture?
Go back to the original picture or just this picture?
Yeah. No, sorry.
The original
I'm
one.
sorry.
The Terry
You were there.
picture.
You were there. Yes.
Oh, this
thank you.
Turk picture. Okay.
The Turk picture. So do you envision that all of the operations will be able to be delegated to the intermediary? I mean, that the intermediary could perform any operation on behalf of the clients?
I mean, I guess I've been imagining this much more like a proxying sort of environment where a client is going to want to send something through an intermediary, specifically because probably the intermediary either has a high volume environment, a good transport relationship to the server, or that it has a different trust relationship to the server than you have. That's like by virtue of it going through that intermediary, you'll get a response that you might not have gotten otherwise if you'd gone directly.
Okay.
But I don't imagine the intermediary taking initiative to make these queries itself, if that's what you're asking.
No, I was just kind of thinking, in the spirit of everyone saying keep it simple. If you do end up having the two flavors of everything, that's sort of direct, I'm a client and I query directly versus an intermediary does it on my behalf, it does change a little bit the what you're asking for, and do you need to indicate that you're asking on behalf of someone and who that is, and so on and so forth.
Yeah.
So that's just what I was thinking about.
Sure. The way we define source in Turk is so that there can be both a query source and a query intermediary. And so you can either you can have one or the either the query source could be obfuscated by the intermediary, which might be desired in some environments, as unfortunate as that might be, or you could have both. Or you could just have the client query go in. So I mean, I think, it makes the policy decision slightly more complex for the server to have to deal with those two different possible fields. But I haven't imagined that's too onerous to date.
Yeah. Okay. Thanks.
I just wanted, Chris, I wanted to address that, or I did address that earlier, but I want to make it explicit again. In my point of view, the intermediary could proxy it, but it could be doing a lot of other things as well. So
yes.
Certainly, my concern would be that we mandate that it has to pass the exact same interface.
Ideally, yes. I would be surprised if there was not a point where I heard a requirement that contradicted that. I would be.
I'm actually unconvinced that we need to specify that. I mean, this goes back to a proxy versus session border back-to-back user agent discussion that many of us have gray hairs to show for. So I would argue that there will always be intermediaries that do various things, from nothing to transport type stuff to essentially acting indirectly where the courier has no idea that they're talking to the carrier and the carrier is actually doing a query on their behalf, strips out half the information that they're not supposed to show to anybody and delivers the rest up. But that's not our problem. That's a policy problem.
I mean, the only, I think, safeguard that is unusual that is present in Turk is envisioned for that is potential digital signatures on the records themselves, so that as they're being transported end to end, you'll have a trust association that will effectively be directly between the client and the authority in that instance. Now, that's just a possibility, right? The architecture will permit that to be possible. That doesn't mean, of course, intermediaries can't strip those records or munge signatures or whatever, right? But there is at least an opportunity for an end-to-end security association to exist in this.
Okay, John, you're out of time.
Okay.
Good fodder for list discussion.
Yeah, so I mean, I guess I just wanted to, is there any hum or temperature taking or sound good? Anybody here think there's problems, disasters, stop, don't do this?
No, but that'll all come out on the list, right?
It will come out on the list, that's true. All right, well, thanks.
Yeah. It'll get there. It's operating slowly. I apologize.
That's not it.
Okay.
Okay, next, please. So this is considered a thought experiment. I translated into PHP and...
It's coming.
Oh, okay. Slowly. It's a thought experiment translated into Python and PHP by two students of mine who have been doing this as a semester kind of project. And the idea is really not to say whatever, and I'm not even going to talk about what protocols they implemented, but is to build a facsimile of a web-based plus API-based, or that's not quite complete yet, system that can do some of the things that a basic number allocation system, either at the enterprise level or beyond, could do. So we took a look at log information, LPA type of information to see what might be in there. Again, to just inform that, we took a look at the kind of issues that arise with authorization. So it's a toy version. We used, as was noted, standard HTTP put post stuff, RESTful type of all the usual buzzword compliance things that you need to do. And the only thing that's just somewhat interesting is we wanted to address, not because it's the only model, but because it's a more challenging one, the distributed allocation functionality. So we implemented a version of what is known as Paxos. I'll talk about that in a little bit, namely that each number is only allocated once, even if two entities, two different carriers, say, request exactly the same block or the same number at essentially the same time. So that consistently, there is a consistent view afterwards that one entity wins or both lose or something happens, but certainly not that the same number has two OCNs attached to them at the same time. That indirectly, simply because of the limitation of these type of consensus protocols, means that it's probably a 20-ish type of limit, not a thousands, although given how inefficient Bitcoin is, and they seem to be run with thousands of systems. Scaling doesn't seem to be a problem once you throw enough money and hardware at it. So we didn't do number policies, scaling. Each server just runs, it's geographically distributed. We actually have 3 servers in 3 different locations doing it right now. And you can actually go there. We allocated the name E164.space. That was the only E164 I could find. And it's not the space that probably that top-level domain is meant for, but hey, it works for us. Next. So the architecture is pretty similar to what we have seen. So we have 3 servers that reflect our architecture, and the slides kind of got messed up. There is a client that does HTTPS JSON requests. There is a separate query protocol that's not quite implemented yet. The intent is to see if Weird's RDAP is going to work for that. That's our current. That seems to be okay, not obviously as is, but as modified. And then there is an internal protocol between these 3 entities, which is essentially the same, except during the allocation, because there has to be the consensus building as to who gets to do the numbers. There's a locking type mechanism, which is not relevant to the client West type of interface there, simply because we assume that each client just does one at a time. They don't ask 2 different registrars or whatever you want to call them in that. Any number can be allocated by any registrar. So there's no block set aside or anything like that. They have access logically to the same space, at least, from what I can. Next. We also wanted to look at what the authorization model would be without specifying, we have a policy implemented, but just to see what that would take. So the basic notion is that each number has, using North American terminology, has an OCN, but think of this as a holder ID, generally speaking. That's an abstract identity. It happens to be an OCN in what we use in a web page. And that has associated a set of authorization, and the notion is that that determines who can modify the record. So if the database registrar believes that you're authorized for that OCN, you get to modify the record, and everybody agrees what that is. That's the abstraction that we use. And then you can subdelegate on that. And we have a separate model, again, just to try out, see what that would do for the type of operations we would need. We've designed a pin-based porting model, namely that, which is other jurisdiction other than the US have implemented. I think the UK has at least talked about it. What you'd have is that gives you read access to kind of the RDAP whois type of properties for your number. When you have that, and it gives you porting access, namely you would provide that pin, whether generated or assigned, to the gaining carrier so that they're authorized, so we avoid the slamming problem that we have in the US, where suddenly in the old days your long distance carrier in particular got changed in some ways. Your local carrier got changed because you got this friendly phone call and somebody told you that they have a special deal to modify your service, and you didn't realize that you signed up with mafiatelecom.org or .com, whatever. So the operations that we need is allocating the number, the consensus, and the porting is just an edit of the OCN essentially. And then, like was mentioned earlier, the synchronization, which is a lost-like synchronization. And we do that exactly like in Lost. Give me all updates after a certain time. Whenever mine crashed, give me all updates after that, and you can do that in a way that is non-destructive. Next. So the one thing that we implemented, which is slightly non-trivial, is we implement a distributed consensus protocol to essentially assume for each number, designate a leader so that they can create that record in a way that you can't have somebody else during that few milliseconds that operation takes place across the various replicas, the logical replicas with different east, west, and south type of places. And it needs to operate in a way where you have instances that may crash. instances that may temporarily be unavailable, and that must still work. You can't have a problem where somebody wakes up and suddenly decides that they should be allocating that number to somebody else. And so these are the standard assumption. This is standard textbook stuff, straight out of Wikipedia, which basically means they can do just about everything except be malicious. So we assume that all these entities behave themselves either because they're nice or because they get kicked out of a club if they're not. Next. We can skip that. So what we do is that we assume that the collision problem is mainly or exclusively a problem during the allocation phase. Because of the OCN model, if you modify, you can never have a problem that the same number gets modified in some way by two entities. If that is a problem, we can apply the same model there as well, if for whatever reason that happens to be an issue. We rely on the quorum mechanism, so we assume that you have n relatively stable, n being a relatively stable number of replicas or servers, whatever you want to call them, nodes. That is known to be relatively stable, and we use a heartbeat mechanism to keep track of that. But we don't care if, as long as the number doesn't change dramatically. If you lose a few, that just means your quorum stays the same, so you have to do more work, but it doesn't break anything, and you assume that adding new entries to that is relatively rare. So the basic protocol mechanism, which is this message between the nodes, is that the proposer, that's the standard terminology that the protocol uses, this algorithm uses, sends a message for leadership period, so there's a timeout one that they send. The other servers say, yep, you're it, because I haven't heard from anybody else that wants that number, or you're not, because somebody else asked at the same time and they got there first. And whoever is the lucky winner, in short, whoever is the lucky winner of that quorum, so if you have two at the same time, presumably somebody gets n over 2 plus 1, and the other one can't, by definition. Then one of two things happen. If somebody wins, you're done. If nobody wins because you have three entities, for example, competing at the same time, unlikely, but could happen, then you try again, and hopefully somebody else will win at that point. I mean, that should be extremely rare, except possibly in cases for the 800 number when they open up. But generally speaking, I mean, I can't see that would happen statistically, that should not happen. Or it should happen with rare instances. Next, please. So let's talk about the prototype. This is kind of a web version of that. So you have, when we populated that with standard information that we would presumably have in an information model. You can list it, you can do admin, you can do all the other stuff. Next. And you can fill that out as you would expect. Next. Oh, and this is just the implementation detail. So we have each node is a set of databases, or a database, a PHP web server which produces the front end, and a Python daemon which does all the RESTful stuff. Next. In case you care, it's standard, all the standard stuff that you would use in a system. Nothing terribly exciting. All I would say is, I said, the protocol quote definition about when the students voted up was less than 10 pages of stuff, because it's really just, here's a JSON object, post it to certain URLs and some error codes. I mean, it's really not terribly complicated. And that's that, and I'll gladly take questions.
Andy Newton. So the RDAP component, did you implement that, or?
No, that's in progress, as they say. And I'd actually like to hear from people who actually like you as to whether we should just abandon all hope in their effort because it's a really bad idea, or whether that's actually worth just trying out and see what we can do. I mean, it's obviously not going to be RDAP correctly because there is no profile for numbers at the moment, so we have to kind of wing it. But if the basic model doesn't seem to work, let me and others know, and then we can just save ourselves some work.
I mean, I can certainly look at it. I see a benefit in trying to do that, in that the people who are writing clients to access those other types of registries that the WEIRD's working group did address can take those clients and without a lot of modification access these registries.
That's exactly the reason we wanted to do it, is that in many cases particularly because I imagine that we will have other, even though it's not really part of our immediate scope, there will be other kind of namespaces, like short codes and other stuff. I don't want to create something new for each one of those, and the boundary between domain names and SIP URLs and telephone numbers is a little blurry anyway. So my hope is that it can make work, but I will report back in case and I'll consult your experiences.
Yeah, if you have some sort of informal document or anything already on that, I'll take a look at it. So
I will. It's really. It's a PowerPoint slide, so I'll send you what I got.
That'll work.
Chris went just a basic question with the PIN. I'm assuming you're implying some sort of.
Can you speak up a little bit?
Sorry. With the PIN, I'm assuming you're talking about or implying some sort of secure token mechanism or
yes,
that type of thing.
Yeah. So the idea would be, and just to it's very simple. I think this is inspired, if that's the word, by the registry transfer model. Namely, you get I don't know what they call that. I'm not a registry guy, the DNS registry guy, but if you wanted to move out, the idea would be the system, so not everybody uses 1, 2, 3, 4, would give you a 6-digit number. You would either type that into a web page of the gaining carrier, so that everybody knows that they're now authorized to talk to the losing carrier, because the losing carrier can validate that. We actually store the hash of the thing in the database, to be precise, and so that they can validate to everybody's satisfaction that the consumer must have given permission, unless somebody broke into the database, must have given permission to do the port, which is the problem. As you know, when you do porting right now, this is a rather cumbersome process because you have to do the third-party validation, which is via voice call, and is all. It's necessary because we have plenty of slamming experience, but I want to do something that is a little bit better. The reason for that is just primarily it complicates the state transition a little bit, because now you have to worry about. What we haven't done is you want to send a set, and I know the existing LNPA does that. Lots of notifications get sent. And it's not just the model we've been talking about all today is largely a request response model. But what we will also need, and that was obvious when we built that, is in a real system what you would need is actually that when these type of things happen, that you have to reach out and notify, like the losing carrier, for example, that the OCN on a number just changed, meaning you just lost that customer, and you can turn off the service at that point. So you don't, as you know, you don't want to have a gap in service. You want to turn it off, and when a second later, the routing should work on the new service.
Right. Yeah, I guess I'm thinking, would that have to be a direct model, or could it be an indirect model, like a provably indirect model, that a service provider proves that the customer did give validation via some token, and then it's an automated process?
And I certainly have not explored the design space there, but I just, at some point we may need to pick that in. That's probably more, which is the data element. You store it as a hash, you store it whatever. So.
John Peterson, once again with my how are we organizing the work here and what are we doing in the working group kind of sense. Seems like awesome stuff. We should definitely start figuring out where it fits in. So where do you think it fits in, I guess, is my first question. Obviously, we need some text in the problem statement, I think, that better articulates what the advantages of the distributed model are, what the trade-offs are, and things like that. But are you envisioning that there's going to be a protocol specification that's going to emerge from this, that's going to explain how?
So exactly. What I'm hoping to do is kind of being, personally at least, being informed by kind of requirements of putting together at least a crude toy, very basic type of system that probably isn't good for much more than a small enterprise scale, but it seems, at least when I looked at the LNPA websites, it didn't seem all that different.
Fair enough.
Except that, paper websites didn't have CSS at the time. But the idea is hopefully that can inform, without being the protocol bits, as to the kind of messages we would need, and how they would be encoded. That's kind of my hope.
Okay.
And I'm happy to work with you or anybody else on
Love to.
drafting that.
Okay, if that's it, then we're done. The blue sheets are up here if anybody has not signed in yet. I guess you get 6 minutes back to your day.